This program demonstrates how to return more than one value from a function. We understood from our previous examples that if we send a address, that is address of a variable into a function, whatever changes we really do in that address will be seen in the Kali program or main. This we wanted to use and return the average, maxima and minima of a one-dimensional array which will be sent as an argument for the function stat1. That is, whatever values we wanted to return from this function, we propose to store in these addresses. Thus, in the main, they can be accessed through the respective variables. Variables S, max, min and I are declared in the function. S, max, min values will be taken as the first element of the array. A for loop is written to traverse the remaining elements of the array. Each time one element is taken, that will be added to the variable S, and that is compared with the maxima. If it is more than maxima, that value will be assigned to max. Similarly, the same will be compared with the minima. If it is less than minima, the same will be taken as minima. This is repeated on all the remaining elements. Once we come out from the for loop, S contains some of the elements of the array, max contains the largest element of the array, min contains the lowest element of the array. We know that in this function x, y, z are pointer variables. Thus, their values will be some addresses. From this function, we wanted to return the average, maxima and minima. Thus, we have proposed to send 3 addresses into the function. In those addresses, we would like to store the values whatever we wanted to return. That is the theme behind this function. Thus, we have written a statement star x is equal to s by n. S is the total of the array elements by n average. That average we are assigning to star x. That is the value available in the memory pointed by the pointer variable x is equal to average. Similarly, star y is equal to max. That is max variable value is stored in the memory pointed by the pointer variable y. Similarly, star z is equal to minima. This one makes the minima variable value to be stored in the memory pointed by the pointer variable z. In the main program, the variables avg, amax, amin are declared. Also, a array is declared. In the table, we have shown the memory and related addresses of these variables and array elements. We have assumed that the address of the variable avg is 10018. Thus, the address of a max becomes 10020, a min becomes 10022, and 10024 onwards, the array elements are seen. For the explanation's sake only, we have considered this example. From the main, stat1 function is called. Remember, according to the prototype of this function, first argument for this function is a 1D integer array. Here in the main, a is a 1D integer array that is passed, and second argument is number of elements. In the array A, 5 elements are there, thus we are sending 5, and the function requires 3 integer addresses. Rather, we are supposed to send 3 integer addresses into which we wanted average, max, minima of the array should come. Thus, we are sending the address of the variable avg, that is 10018 we are sending, and address of the variable a max, that is 10020 we are sending, and also the address of the variable a min, that is 10022 we are sending. That's how the function is called. One important aspect you are supposed to remember is, in C language, array name itself is a pointer to the array. I am sure that you will recall, while reading a data into a string variable, we never applied ampersand to the string variable. We know that scanf function requires address as a second argument. As the string variable name itself, that is 1D array, name itself is a pointer to the array, we never applied ampersand to the string variable name. In the same fashion, here A, when we are sending, means we are sending the starting address of the array to the function. Array name is itself is pointer to the array. So, which means that into the function we are sending 10024. Let us try to simulate how this function call works and also how the function works. We wanted to explain in terms of addresses also. Already we know that whenever a function call will be made, the memory required for the arguments, formal arguments, and the variables inside the function will be allocated. Now, memory for the variable p will be allocated. P is the array name that itself is a pointer. From the main program, we are sending the address 10024. Thus, p value becomes 10024. Memory for the variable n will be also allocated. N value becomes 5 as from the main we are sending 5 as the second argument. Memory for the variable x will be allocated. From the main, we are sending the address of the variable avg, that is 10018, dash x value becomes 10018. Memory for the variable y also will be allocated. From the main, we are sending the address of the variable a max, that is 10020, dash y value becomes 10020. Similarly, memory for the variable z will be allocated, and from the main, as we are sending 10022, that is the address of the variable a min, the same will be assigned to the variable z. In the function, we have declared local variables such as s, max, min, and I. For these variables also, memory will be allocated. Thus, for s also, memory will be allocated. First element of the array P0, that is 10, will be assigned to the variable s. Memory for the local variable max will be also allocated. For that also, first element of the array P0, that is 10, is assigned. Also, memory for the local variable min is allocated. For that also, first element of the array P0, that is 10, is assigned. Memory for the variable I is allocated. The for loop will be executed. The initial value of I is 1. P of I, that is 20, will be added to the variable s. Thus, s value becomes 30. P of I, 20, is greater than maxima. That is, max value is 10. Yes. Thus, max becomes 20. As P of I, that is 20, greater than minima, minima value will not be updated. I value will be incremented by 1. Is I less than n? Yes. P of I, 30, will be added to s. Thus, s value becomes 60. P of I is greater than max, that is 30 greater than 20? Yes. Thus, max value becomes 30. As P of I, 30, is more than minima, minima will not be updated. I value will be incremented by 1. Is I less than n? Yes. I value is 3, P of I 50, that is added to s, thus s value becomes 110. As P of I is greater than max, max value becomes 50. As P of I greater than minima, minima will not be updated. I value will be incremented by 1. Is I less than n? Yes. I value is 4. P of I, that is 2, that will be added to the variable s. S value becomes 112. P of I, that is 2, as it is not more than max, max will not be updated. However, as Pi, that is 2, it is less than min, thus 2 will be assigned to min. By this time, we have traversed all the elements of the array. Now S contains the total of the array elements, max contains the largest of the array elements, min contains the smallest of the array elements. Now the statement star x is equal to S by n will be executed. That is, S by n value will be stored in the memory pointed by the pointer variable x. What is the value of x? 10018. Which memory it is pointing? 10018. Whose memory is that variable? That the memory of the variable avg of the main. That means that we are assigning S by n value to the variable avg of the main from this function. Now star y is equal to max statement will be executed, which means that the value of the variable max will be stored in the memory pointed by the pointer variable y, that is in the memory 10020. 10020 is the address of the variable a max of the main, which means that we are assigning the max value to this variable a max from the function itself. Now the statement star z is equal to min will be executed. That is, the value of the variable min, that is 2, will be stored in the memory pointed by the pointer variable z, that is 10022. Remember, the 10022 address is the address of the variable a min of the main program, which is sent as the argument for the function. Thus, a min value becomes 2. That is, we are changing the a min value from the function, and the same may be visible in the main. Memory which was allocated for the variable I will be deallocated. Memory which was allocated for the variable min will be deallocated now. Memory which was allocated for the variable max will be deallocated now. Memory which was allocated for the variable s will be deallocated now. Memory of z will be deallocated now. Memory of y will be deallocated now. Memory of x variable will be deallocated now. Memory of n variable will be deallocated now. Memory of the variable p will be deallocated now. We are back in the main. The last printf statement will print average, maxima and minima of the array. This program